Welcome, or hopefully welcome back to another episode of Reliability Matters, the podcast where we dive deep into what it takes to build reliable electronic assemblies. Today, I'm joined by two of the most respected names in the electronics manufacturing industry, Phil Zarrow and Jim Hall. Together, they bring decades of hands-on experience and unparalleled insight into the challenges and solutions within our field. Jim and Phil are the driving forces behind ITM Consulting, where they help manufacturers around the world improve processes, solve complex problems, and build more reliable products. Whether it's soldering, cleaning, reflow profiling, process control, or failure analysis, these two have seen it all, fixed it all, and taught it all. In this episode, we tackle some of the most pressing issues facing the industry today, from the challenges of miniaturization, the reality of voiding, to the rise of electronics deployed into harsh environments, to IPC standards and the role of process control in ensuring long-term reliability. Whether you're a process engineer, a quality manager, or simply passionate about electronics manufacturing, this is a conversation you won't want to miss. Let's get started.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Hey, fellas, I guess you haven't solved all the problems yet because, look, you still show up to work.
Yeah. Welcome, Mike. Good to be here.
It's good to have you
here, Mike. Thanks.
It's been a minute. It's been a while since we've talked, so I'm glad to see you guys. And just for my audience sake, we are all over the place. I'm in California. Phil, you're down south of the equator where the water turns backwards in the bathtub, right?
Yeah, just about on the equator. Yes,
on the equator.
Yeah.
So the water doesn't turn at all right there, right?
No, it doesn't. It goes back in your face. Real pain when you're falling to the toilet.
And Jim, I think you are about 60 feet from the Atlantic Ocean right now. You're on a beach somewhere, right?
That's right. I'm on the Jersey Shore.
At the Jersey Shore, right? This is our version of Jersey Shore right here. Maybe a little less controversial. Well, thanks for joining me. It's good to see your faces and hear your voices. What's going on in the electronics industry right now, from your perspective? What are some of the persistent challenges that keep you going south of the equator and keep you going to the beach? You know, that keep the wheels of ITM turning.
Oh, where to begin? There of course with things like continued miniaturization and some of the other challenges with regard to which we'll talk about, I guess, with low temperatures. We actually still see a lot of the old problems, same old, and which obviously have a major impact on reliability. But some of these things just won't go away.
Yeah. Yeah, in my business, you're in a very wide industry, meaning you cover, engineering and assembly and, all the things to do with that. My business is way down a rabbit hole. I'm in the cleaning world, cleaning, contamination, quantification. And in our little world, the same things, it's wash, rinse, repeat, right? It's just, throw the record on again. And I'm sure in your industry, there are some of those things that just they have a life of their own, right? Next generation discovers it like it's the first time it's ever been discovered, and you realize this is just, that they just discovered the same record that their parents had, that their grandparents had. It would like voiding or would that be one of them?
Miniaturization, Mike. Miniaturization has been going on since day one, right? When we moved from two-hole to surface mount. Why did we do that? Miniaturization. Immediately shrink the board by 75% on horizontal area, and it continues to go on. And as it does, this thing gets smaller and smaller. It begins to hit to all the process steps and all the materials. All of a sudden, the powder in your solder paste is too big to go through the holes in the aperture, and in the holes in the apertures, the stencils, the walls are too rough, so that it sticks in these. So you got to change the stencil material, and then You need different nozzles in your pickup machine. And then you need a higher resolution camera on your AOI machine to accurately, make the images of these components. And then, as they get smaller and smaller, some other process will be affected.
Yeah, I was at the UHDI conference earlier this year, the SMTA Ultra High Density Interconnect Conference in Peoria, Arizona. And I was not speaking there because that's well beyond my pay grade, that stuff. If I can't see it, it's hard to speak on it, So, I can see things I can quantify. I can talk about things I can quantify and see. This stuff, these old eyes can't even see it. I have an image in my PowerPoint presentations that I give of a U.S. quarter coin, and there are about 4 components on the edge of the quarter, front to back. And they can fit 4 side by side on the edge of a quarter. I know there's better ways to describe it, but that just blows me away. Yeah.
One of the most common, seemingly trivial activities is loading a reel of components into a tape and reel feeder to put on a pick and place machine. You put the reel in, load the tape into the sprocket mechanism, pull back the cover tape, and then you advance it until you get to a pocket that has a component in it. But now, without magnification, you can't see the component in the pocket. So even something as simple and basic as loading a tape and reel feeder has been impacted by ultra miniaturization.
Yeah. Yeah, we do live in interesting times. Miniaturization in the cleaning world obviously is impacted. It keeps me in business and in all the peripheral companies selling chemicals and things like that. And it's fascinating the amount of power that we can get, computing power, for example, in such a small space. I mean, it makes wearables possible. It makes IoT possible. It makes implantable medical devices more possible. It's fascinating and challenging in so many ways. I mean, like you said, Jim, just not being able to see the part when you're loading a tape and reel into a pick and place machine. From a contamination standpoint, from a thermal management standpoint, all these areas in our industry that miniaturization touches in challenging ways it's going to keep the next generation up at night for sure. What are some of the biggest misconceptions that manufacturers still have about soldering defects and their root causes?
Well, let's see. Well, we talk about actual
limited to
soldering,
300 or 400 misconceptions.
Yeah, I mean, we still run into, as incredible as it seems, we still run into the one profile does all syndrome, where people don't bother to profile, do a DOE on each of the applications. And that board looks close enough to the other one. Let's use the same settings. So we still see that. And, this goes back to the dawn of time. And then again, the fact that sometimes people get tunnel vision, and miniaturization is a great example, as you and Jim have alluded to already. We think, miniaturization, will I pick a place machine be able to handle it? Will I have real feeders be able to handle it? Yet it's the entire process. As Jim said, the implications on printing, and your solder paste and everything else. So that's another one. Another urban myth that comes to mind is that all solder pastes are created equal, and that's obviously a sign of somebody who's never done an evaluation before. And take it, Jim.
Yeah, Jim and I were talking just before you came on, Phil, and before we came on camera. Jim has a really interesting take, a really pragmatic, interesting take on reflow profiles and things like that. So we're just gonna call this segment of the show the Jim Hall Show.
Take it, Jim.
Okay. You still have your soapbox next to you, because it's time.
Yep, I'm on my soapbox. I started in this industry in 1980 with vapor phase when reflow soldering was just becoming a mainstream technology, and I've been worked with Dynapert and Victronics and Soltec and so forth. And the reality of focusing for you, like on reliability, um, in my opinion, very little real work has been done correlating the parameters of your reflow profile with the ultimate reliability of your solder joints. Most people use one profile. It's actually what Phil meant is one recipe meets all, one machine setting. But even if you do it right, but people will say, well, one profile meets all, and I have to adjust my oven settings for individual boards to get that profile on the board. But is that optimal? If I use the example of the straight ramp profile, your principal variable is the heating slope, right? Well, the paste manufacturer gives you a wide window to work in. So suppose I'm heating at 0.9 degrees per second. If I went to 0.8 degrees per second or 1 degree per second, would I get more reliable solder joints? And in my experience and knowledge, very little work has been done to do that. And you have a profile, say 9 degrees, 0.9 degrees per second works. So I'll just stay with it. But theoretically, maybe if we change the profile, we would get better results. But the big problem is, with anything, to evaluate that, you have to reprofile, and then you have to make some solder joints, and you have to inspect them, or more importantly, reliability test them. And one of the principal reliability tests is thermal cycling, and that takes a long time and is really expensive. So that really limits your ability. One crazy theory that I have is the correlations that a number of people have shown between shear testing and thermal cycling, using a shear test to give you the same kind of information that a thermal cycle test does. And of course, shear test is very quick and cheap. So my vision is somebody should evaluate their different thermal profiles, and then just solder some simple samples and shear test them, and perhaps use that to get a better understanding of this relationship between the heating parameters within the profile, such as the ramp or peak temperature, time above liquids. You could do it for any of them, and long-term reliability.
When my daughter was a teenager, she used to have this phrase which drove me crazy. When we asked her how she liked something, her answer would be, "Well, this doesn't suck." And I'm thinking that if someone is testing a profile and it doesn't suck, the parts are still there, it doesn't look terrible, nothing got burned, the solder joints don't look cold, then it doesn't suck. It's good enough. Maybe this is a good as the enemy of great kind of thing, right? Because who has the time and the money to destructive tests 500 boards or a dozen boards even, just to get something maybe a little bit better if it's good enough? That's probably the pragmatic reason why that's the case.
The only example that I know of for that where it has been done, different profiles have been tried, is to look at voiding in the center pads of PTC components. And the reason for that is because as a contract assembler, if you got voids, the cheapest thing you can do is change your reflow profile. You don't have to change your stencil or your paste or anything else. And you can get, you just have to solder one board and X-ray it, and you get immediately an answer to whether or not you increase voiding or not. So there is some data, published data about that, showing that different choke profiles and soak times and so forth reduce voiding. And I believe it's because it was the testing was relatively simple.
Interesting. I'm going to take us off a technical topic just for a moment because this just came in my head, and then we'll dive back into the technical side. You guys have been teaching courses at various conferences around the world, since I don't know, 2 centuries ago, and
that's how we met.
Or it seems right, like dog ears. And you have both online and live workshop, courses and things like that. Written papers. You've been around the block. Do you see a difference in the younger generation that's coming into our industry in how they learn? Do they attend the conferences? Do they attend the workshops? Do they watch webinars? Do they learn the same way, or are you having to, if you were decide to stay in business for yet another 100 years, what would you do differently in terms of, how you broadcast your information, how you seek to train the engineers that come to you for help?
That's an interesting statement, Mike, on a couple levels. First of all, we're always glad to see, and we're seeing the younger and younger relative to us engineers in the conference, and we had an experience a few years ago where we teach a lot at Apex and S&PAI and some of the others, and I was making a comparison about in terms of the accuracy of inspection, I think it was, and I cited an HP study from 1985. And I go, you guys remember 1985, boards were, our smallest component was an 0805 and things like that. And Jim interrupts, he says, Phil, most of these people weren't even born in 1985. And it's like, oh my God, when will we become the oldest guys in the room? So we have that. The other thing we've noticed is, I think currently a lot of engineers, and is making a generalization, or people in the current generation learn more graphically, I think, than we did, I guess. And that's just, sign of the time, sign of the technology we have, and things like that. This moment is a perfect example. Of course, you have to put up with our two faces made for radio. But one of the things we notice, we've done board talk. We'll have an audience and we'll talk to people. And generally, if they're under 35, you say, we watch board talk. Whereas if they're typically over 35, it says, yes, I read, in other words, transcripts of board talk. And so that's very telling right there. So we present them in both formats. We try to, express ourselves well, in writing it and in presentations and graphics and things like that and examples. Jim, you want to add to that?
Yes, certainly for long term, you have to think in terms of pre-recorded on demand so that people can access the information when they want to, not on a schedule at an event that they have to go to, or even a live webinar, so that they can fit it into their schedule.
Yeah, that's what I love about this podcast. This and all podcasts is it's perpetual. It's evergreen. This is episode number 175. There are 174 episodes before this one, and people discover the podcast when they discover the podcast. So some discover it on episode 12, some discover it on episode 1, or this might be we might have someone in the audience that this is the first one they've seen. God help us if that's the case. I think any generation, you've officially become your father when you start a conversation with kids these days, right? But I'll say it anyway. Kids these days, they watch, they learn, they obtain knowledge on their time, at their convenience, at 3 a.m, at 1 p.m, anywhere in between, which is, to your point, keep it on demand, keep it available, have it in multiple formats, have it, in audio, have it visual, kinesthetic, at live workshops, in writing, people who like to read papers. All these different learning techniques and preferences. If you can make it available multimodal, then I think that hits every generation, right? And you don't have to come up with something just for one generation. It's keep it wide. From a failure analysis perspective, what are the most preventable causes of premature field failures, and how can manufacturers better address them? What's the easy one? How do you shoot fish in a barrel when someone comes to you?
Well, besides looking for the usual low-hanging fruit, as we like to call it, which is the same old that we mentioned earlier. Our approach to failure analysis, or what to make a distinction of process failure analysis, which some people would call troubleshooting, but that sounds too much like a appliance repair guy. So what we do is actually process failure analysis. Well, a lot of times it'll be in conjunction with an FA lab. They'll tell you, yep, your problem's headed below. Well, we're the ones that will go out to the process and tell you, what the probable causes are, or the root cause and things like that. So uh, our typical approach is, because people make the mistake of getting tunnel vision and focusing on one thing, whereas all the processes are all interconnected and interrelated. So typically our method of operation is we take a good overall view of the entire process. One of our colleagues, Bob Klenke, likes to call it a walkabout. We'll look at the entire process, and then we're going to hone in on the usual suspects, some of the other suspects, but we'll take 1,000-foot view and then come in and take a look. And a lot of times, depending on the problem, we know from experience that, probably the main contributor there is printing, or main thing there is, that does not look like a properly reflowed board, things along those lines. So, but the key thing is that we would, profess is that you have to look at the overall and understand and keep in mind everything from the minute the components and the materials of the board come into the factory till they're actually packed up and shipped. Everything can be, a contributing factor. Jim, you want to elaborate on that?
No, I think you covered it well, Phil.
Okay.
Enough said.
We all like
right?
shoot fish in a barrel, but unfortunately, there's not a lot. Now, maybe I would say that gaps in people's background. There's very few systematic training courses for surface mount assembly or electronic assembly, and so people learn like the way you learn your weight processing. You learn the things you need to solve your problem, to do your job and solve your problems today. And so people can become experienced in terms of years and have holes in their knowledge. And that will be, can be a big source of defects and so forth, because they just aren't focused on one particular aspect that in this particular situation has become critical.
What's your take on standards? Let's talk about IPC standards for a moment. Are they generally understood? Are they misunderstood? Are they used properly? Are they misused? Do you have any experience with any specific standards that are problematic in your world? Or, let's talk about standards in general.
Okay. Well, I think that one of the things, I would add to your list of adjectives there is that a lot of times, or adverbs, I got to think about that. But anyway, when they're misused in the sense that people treat the standards as, the holy scripture. And we know people who can cite, item well in IPC 610.222, and they know it. But the problem is that in itself, we're using 610 as an example. It's a generic spec. It's trying to cover everything everybody's building. And you can't have something like that. So what we urge people to do is, yes, 610 is a beautiful document and it's a great place to start, but use your brain, look at your application. What's the service environment of the product that, either yours or the customers, and the entire picture, and then adjust your standards to fit what the product actually needs. A good example is a few years ago, Jim and I were working with a customer. In this case, it was an inverter for a solar panels, and they there were some other things. Whereas the president of the company wanted to have like a 20-year warranty on something that cost $100, was easily repairable. But that's a story in its own thing. But here's the thing: so our project was to basically audit some candidate contract assemblers that they were considering, and help them select the ideal one. We enjoy doing that. Anyway, one of the things we cited was, here you had something that was, the environment was rather challenging in a sense that, think of an inverter up there on the back of a solar panel. It's going to be subject to vibration, temperature swings, cycling, salt spray, everything else. So your reaction as well. Maybe that's should be a class 3, reliability expectations. And the reality, on the other hand, some things aspect of it would be overkill. So we basically said, well, probably build it to class 2.5. And suddenly you see, I go, what are you talking about? And a while later, we got an email chain from the customer and said, where's what is IPC 2.5? I think a couple pages were missing from my spec, and some of the IPC, that's Zarrow and Hall, they're out of it again. Well, no, it actually isn't. There are other people who refer to it. But the idea is, is something you should take your, basically compose your own workmanship standards and deviate where you have to, make it apropos to what you're building in a service environment is going to see. And, it being treated like a generic spec is not a good idea. Also, where did these specs come from? Where's the data? That's a whole nother topic because, I'll get on it. It's a minor soapbox, but where did, for example, at through hole, where did 75% hole fill come from? Anybody know? Jim was mentioning, data, with regard to shear test. We talked about pull test. Well, a few years ago, I conversation I was having with a customer, we said, wonder where it did come from. So, immediately we go back, we go digging through the archives, and the immediate thought was it came to some of the big, some of the big OEMs, in the mid 60s or something like that, like IBM or Western Electric ATT, or, somebody like that. Couldn't find anything. We dug deeper and deeper. And, must have come from maybe the mill specs, because IPC, the original IPC specs were derived from mill specs. Good old China Lake.
6536. And
there you go. Wow, you're good, man. You ought to form a trivia contest for,
I know, right? Right.
Yeah.
I can't remember what I had for breakfast this morning, but I'll remember, the 1970s mill standard.
Exactly. So I brainstorm hit me. I went back to the late great Jim Raby, was still alive at the time, and a good friend of mine, and he headed up China Lake, back in the 60s. So I wrote him an email. I said, hey, Jim, where do these specs come from? Where's the data? Didn't hear back from him. So about a month later, I was having lunch with him down in Huntsville, and Jim said, hey, remember the email you sent me? I go, yeah. He says, well, there's no data. What? He says, no, there is no data. I said, Phil, this was the Cold War. We were building missiles. The Russians were building missiles. This worked. This didn't. Boom, that becomes a spec. 75% of hole fill. Wow, empirical, man. But I'm happy to say that, nowadays there is a lot more finite data that, in tests that, that support, things like, for example, the specification on ENIG and things like that. But then again, there's been some other mysterious things. The original allowance for voiding in a BGA, if my little mind remembers correctly, was for class 2 and 3, you were allowed up to 30% voiding. And then if you were military, class 3, you were allowed up to 25%. And all of a sudden, 30% became okay for everybody. Wow, how'd that happen? The Earth shipped on its axis or something. So, you've got to think for yourself. And I think that's true the entire process, but certainly in the area of specifications, things like that. They're great guidelines, start there, but what makes sense?
Jim, anything to add?
No, I agree. You've got to take responsibility for your own quality.
Yeah.
And don't make it harder. And don't make it harder than you have to. Part of that type 2, type 3. If you don't need one of the aspects of type 3, don't apply it. It only makes your life harder and it's not giving you any benefit.
Yeah, I think a lot of people forget there's usually a sentence at the end of each declarative command that says, or as agreed between manufacturer and user.
Right.
And that is kind of a get out of jail free card for a lot of people. I'll tell you the standard that I appreciate the most, because I'm very familiar with it and I teach courses on it, but I think it's unique amongst other IPC standards, and that is the J standard 001 J, I think they're on now, but specifically Section 8, which covers cleaning. That's my world. Because prior to September of 2018, when there was an amendum to Section 8 in the G version of the J standard at the time, prior to that time, the pass-fail level in terms of measurable contamination on a circuit board was 1.56 micrograms of sodium equivalent per centimeter squared. 1.57, your board is dirty. 1.56, it's almost dirty, right? And that was established in the 1970s, when engineers on their way to work were listening to Linda Ronstadt on their 8-track player driving their Chevy Nova, right? That's the context in which that standard was made. And much to your point earlier, Phil, that standard, from my understanding, if the tribal, information is correct, the people who kind of suggested that standard as a talking point were rather horrified to find out it made it into a standard, right? That was just kind of their working title for pass-fail, and then it made it into a standard. The new version of that standard is when people ask me, how do I interpret the new J standard in terms of cleanliness? And I turn the answer into the form of a conversation. Imagine someone talking to IPC. That someone says, hey, IPC, how clean do my circuit boards have to be? IPC says, I don't know. You tell me and show me the evidence. How you came up with that. That's the standard. Yeah. That, in a nutshell, is the standard. So you and I can be all complying. I could have the equivalent of 1,000 micrograms of sodium per square inch and still meet the standard. You could have 0.01 and meet the standard. And Jim can be somewhere in the middle. So to me, that's a brilliant standard because it is not an arbitrary number. It is a number you have to provide and prove through testing that it did not fail under a harsh environment condition, which is the worst case. And if it can survive in the worst case, it's clean enough. And you have some degree of both anecdotal and scientific evidence to back that up. So I think that's a brilliant standard. Now, if that could be done with voiding, that'd be great, right? If that could be done with other things, that could be great. But, fillet measurements and, solder coverage, all that kind of stuff. But obviously, we can't do that. We can't, that would be, death by testing if that was the case. Are you seeing any trends with alternate alloys, low temp solders, things like that? Is that coming into your world, or is your world more traditional, leaded and lead-free, SAC 305 or whatever? What's your take on all these fancy alloys and low temp stuff that's coming out?
Well, we obviously try to stay informed and aware of the latest, greatest in the impact and the attributes and everything else. And, it's part of our job on it. We try to keep tabs on the latest research and the findings. And actually, Jim is our technical archivist and studier, but it's just interesting that we look at the latest, greatest. For example, in terms of strive for lower temperature solders. Yet, by the same token, things that a lot of people take for granted now, like lead free, and focusing on that, we still would deal with people who are still using tin lead alloys. There's still a whole lot of them out there. So we try to look at the entire spectrum of things and keep tabs on it. I think that's yeah. Go ahead, Jim.
Mike, I don't have a lot of hands-on experience. We did one of the early applications with it where it worked really well for a specific customer with a very specific need. But I think if we step back and look at all the benefits that are being discovered and identified with going to lower temperatures, I mean, I think my personal feeling is the main driver was head and pillow defects and warping BGA packages. BGA packages get more complex internally. They're going to warp more. It's difficult to control the warpage. So if we can solder them at a lower temperature, and head and pillow is the worst defect you could possibly make because it's hard to find, it's hard to test, and if it does get in the field, it becomes an intermittent, which is the worst thing you can have. And that was the main driver. But now people say, well, wait a minute, I'm going to save a whole lot of money on my reflow oven, power to my reflow oven, because I'm not going to run this so hot. And people are saying, oh, and hey, I'm going to be able to use less expensive materials. And people were saying, and hey, maybe I can do a lot more pin and paste, because one of the big limitations with pin and paste is reflow soldering through hole components. But one of the main limitations for years has been that a lot of the through hole components can't withstand the higher reflow temperatures, even for chin lead. But now, if you only reflowing at 190, your window for using through hole components in a pin and paste environment grows. So you start to stack all of those up, and I think there's going to be a tremendous drive to go to lower temperatures. Heat, as I always say to my students, other than promoting solder wetting, high temperatures does no good for anything on your circuit board. Right? It does so forth.
Interesting.
And also, as Phil said, looking at what's going on, to me it's exciting. Having gone through the whole struggle with lead free to get to SAC 305, we have the development and qualification of low temperature alloys is going so much faster because we're just so much smarter in terms of evaluating solder alloys and the use of dopants and microalloying and so forth. So I think we can get there a lot faster, and there's a lot of economic impetus to go to lower temperatures.
So in my world, in the cleaning world, I've been diving into thermal management topics recently. Ironically, not to protect the device from overheating, but poor thermal management in the cool down portion can create microclimates, which can create moisture, which can react with residues, which can create ECM events. So basically, we can create a harsh environment within an enclosure in a safe environment, and it has to do with too rapid of cooling and creating hitting a dew point within the enclosure. So the only reason I mention that is do you guys have experience with your clients coming to you with thermal management issues, either for the traditional take on thermal management, which is to avoid overheating of components, or the latter, which would be too rapid of a cool down? Does that land in your consulting world, or is that out there too far? Are you too busy with voiding and other things and tombstoning and head and pillow to deal with thermal management as well?
We've had, again, everything, is application driven. And we have had situations where customers have come up to what could I do to control the thermal aspects. And in some cases, it might be a lower temp solder or, methodology or tightening up your reflow profile, things along those lines. So we do nothing. Nothing comes immediately to mind, as an example, Mike. Jim might have some thoughts, but it's all part of the program. We do get people involved in thermal, and as Jim said, underlying everything is excess heat does nobody no good. The goal is to, in terms of whenever we're optimizing any process that's has any thermal involvement, so to speak, we always do try to optimize things for the most comfortable conditions possible.
Having been an oven designer for 20 or more years, we dealt with cool down sections, and this became significant with again advanced VGA components, because cool down is affecting the warpage. And I always, whenever I teach basic reflow, I make this statement to my students. I said, the cooling section is the most important part of the reflow. And everybody goes, huh? Oh, why is that? And I said, well, what does your customer want? They want a reliable, solid solder joint. Where do you create a solid solder joint? In the cool down section. And expanding on that, we know that cool down affects not only the components, but the grain structure of the solder alloys and so forth, which with the multi-alloy, with multi-component solder formulations is becoming and going to continue to be more and more important. So certainly controlling cooling in your reflow sections, and I guess you apply that to any soldering operation is significant.
Right. Do you guys have any technologies or tricks or process tools that you think are underutilized in the average electronic assembly facility that may otherwise improve or provide the biggest ROI if it was adopted? Are there certain things that we're just constantly missing?
Design of experiments.
Yes,
People
absolutely.
still continue to try to optimize their processes with single variable optimizations. And as Phil has said, we all know everything is interrelated. And if you have an interrelated process and you try changing just one variable, you're probably not going to be very effective in an optimization or a problem solving, troubleshooting environment. So they use the basic designed experiments where you identify the all of the significant variables and run your optimization tests in a statistically structured manner so that you evaluate all of them, all the critical ones, the interactions with a minimum amount of testing, giving you the best data. I think is one of the most fundamental things that's not done. If you think about a stencil printing, and anytime you set up a new board in a stencil printer, you got to pick a speed and a pressure, but they're interrelated. So if you sit there with your new board and just change the speed and then change the pressure independently, you're not going to be as successful or as efficient in getting to an optimal process.
Yeah, that makes sense. How do you see AI, artificial intelligence, and machine learning shaping the future of process control or inspection or wherever else it's landing in our industry?
Um, I think we're going to see more and more application of it. There are certain aspects of it that actually have been played with and experimented with over 30, 35 years ago, such as what we used to call adaptive intelligence. And but the idea, I mean, one of the areas we're seeing now is more closed loop. The idea that an SPI or an AOI machine will actually analyze the data, process it, and then go back and look at rectifying the cause on the appropriate process, the printer or whatever. And actually, that, as I said, that was experimented with 35 years ago, and it was But now we have more of the power and the ability to do that. So that's an interesting application of AI. I think as far as doing things like failure analysis, root cause analysis, things like that, I think AI is going to be a very, very powerful tool. We haven't hit the singularity, so to speak, of it. So Jim and I still have gainful employment, haven't replaced us yet. But the potential for AI used properly, it's really, really great. But then again, one of the things that Jim and I were talking about the other day, with regard to AI, approaching that holy grail of electronic manufacturing, the lights out factory. And AI is definitely a major, or can be a major step towards achieving that. And if it ever does exist, so AI, it opens up quite a bit, but it doesn't. It still is not going to replace, again, the human touch, personal knowledge, assessment, and most important, experience. And that still goes a long way. So I'm not afraid of AI in any regard, but it's something I think it's going to be very, very valuable towards as our technology gets more and more challenging. It's going to be can be, if applied properly, very, very helpful.
You said something interesting. I'm not afraid of AI. I think a lot of people are afraid of AI. Almost like people were afraid of the internet. People were afraid of computers. People were afraid of lots of things.
Right.
In our generation of watching technology evolve, we've all shared fears, usually on things we don't quite understand. But
exactly.
I think one of the things that would help is renaming AI. AI, to me, artificial intelligence, is the word artificial creates some degree of fear. And I don't think that's the appropriate name. There's nothing artificial about its answers to questions. To me, it's more acquired intelligence. Keep AI, but change artificial to acquired. Because where did it get it from? It got it from me and you and everyone else who's published, right?
Right.
it has looked at billions of published pieces of literature and papers and postings and things like that. It's a voracious reader, and it's scoured the internet of publications, and it's learning modules. Learn to kind of piece pieces together from this piece of work, that piece of work, that piece of work. But there's nothing really artificial about it. It's acquired it all from us. So I think that creates some fear. What's that, Jim?
I'm afraid of incompetent, unscrupulous people misusing AI and thinking that that it's God and it has the answers and so forth. That's the real thing. As with any new technology, it can be misused, and AI has, I think, really bad potential for misuse.
It definitely can. Yeah. Particularly outside of just text, when it comes to the deep fake videos and things like that are really hard to discern whether they're real or not. The early days of fake videos is pretty easy to know it was a fake. Someone would just paste on a head. Now it's arguably hard to discern the difference between what's real and what's not.
Or I think it's like. Mike, I think it's like all the other technologies you mentioned, is that, the introduction of, computers and, of course, the gaining power there. A lot of the other things is that it is viewed as a Pandora's box, and it's going to be a mixed bag. And, we've all watched enough science fiction or read enough science fiction. Of course, 2001 comes to mind, and good old Hal. And I'm sorry, Mike.
Open the bay doors, Hal. Open the bay doors.
Sorry, Mike, I can't do that.
Yeah. So I can't do that.
But I think Jim makes a very, very valid point. Things could be used for good bit. I personally, curmudgeon that I am, I'm not a big fan of social media. I think that's another Pandora's box. As I speak on social media here,
you will be on social media. Yeah. Some of the people are watching this on LinkedIn right now at this very second.
Exactly. Yeah. So it's the ironies of it all. Yeah. So
I may regret this final question, but I'm going to do it anyway. I'm going to throw caution to the wind. So before we say goodbye, I want to give each of you a chance to say what's on your mind, and any subject, anything. What do you want to say? What would you want my audience, engineers within this industry, to know from the world according to Phil, the world according to Jim? Jim, you take it first.
The industry is growing. It always will. There's always new things. You have to continually learn and train yourself. And if you're in a position of controlling training for employees, it has to be an ongoing thing. Thinking of as a Lean Six Sigma Master Black Belt who teaches continuous improvement, we need to adapt that and adopt that. There's new stuff, so we always have to improve, and we can even get better on the stuff that we've been doing for a while. So training, learning, and being open to growth is really important.
Good advice, Phil.
Yeah, I think along the lines of what Jim's saying, the other thing is to embrace change. It's fun. Embrace the challenge of it. That's the exciting part about our industry. Things are always changing. All the things we've discussed today, and embrace it. Have fun with it. Somebody once told me early on in my career that engineers don't like change. They're afraid of change. Maybe once upon a time, but I don't see that now. So embrace it. Think open-minded. Think creatively, and have fun. Things are constantly evolving. I like to say, we're in a state of flux in this industry. I know 10-yard penalty for an illegal pun, but it's absolutely true. So let's have fun with it. Everything has been invented. It hasn't been invented yet. And boy, we are in the middle of it. And every once in a while, take a step back and just, look at the wonder of it all. It's just fantastic how far we've come. I've been in this industry now for, hate to admit it, 50 years. And it's just absolutely, amazing, where we've come and where we're going and the potential of some of the things we touched on. And the only other thing that I think beyond that I think Jim and I will both advise you is try to avoid people who take things way too seriously, especially themselves.
Well, that's why I love talking to you guys. I mean, you guys can never be accused of taking things too seriously. So,
That's right.
you
At
know
least
what?
ourselves.
One thing about, when I first started going to our conferences within our industry, the old NEPCON conferences, Apex conferences,
Oh,
SMTA
yeah.
conferences, a lot of the presenters were very serious. And
Yep.
when I first started in this industry in 1985, I think by 87 or 88, I spoke at my first conference, and I was in a cold sweat. I had major imposter syndrome.
Right.
And
Right.
my style of presenting is more similar to yours than what was status quo at the time. Status quo was cold, stale, nothing but the
Hmm.
facts, man. Very Joe Friday for my audience that
Yeah,
remembers
exactly.
Dragnet, right? Just the facts,
Right.
ma'am.
Yeah.
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 And I can't do that. That's just not me. I mean, I can't even force myself to do that. I'm not that good an actor to be able to do that. So I thought, okay, I'm going to have my one shot at this. I'm going to crash and burn because I'm a fish out of water. I do not belong here. Remember Highlights magazine when we were kids?
Yeah. Yeah. The dentist's
The-
office. Yeah.
yeah. And there was one part of that magazine every month that had, it was called What Doesn't Belong. And it would show like a drawing of a kitchen. And in the kitchen was a refrigerator, a mixer, a blender, an oven, a sink, and a chainsaw. And obviously you were to circle the chainsaw. I was the
Right.
chainsaw. I did not belong there. And
Yeah.
and I just thought, okay, I can't do it any other way. I'm just going to present my way, which is very, very informal, not stuffy at all. Probably not quite as technical as people expected, but enough to get the point across. And I didn't crash and burn. People liked it, and no one threw eggs at me. So I said, okay, that's just my style, and that's what I appreciate about you guys, and Doug Pauls and Dave Hillman, and between you guys and Hillman and Pauls and a few others, it
Yeah.
it breathes
We're out
some
there.
levity and some light into otherwise a very what could be dry and maybe even boring. And I'm not criticizing people who are that way because we're speaking about dry, boring subjects. We're speaking about engineering stuff, technical stuff.
Right.
But I appreciate the fact that you guys deliver it in a manner that makes it more palatable. Right? You're putting sugar on the
Well,
castor oil.
Mike,
it's interesting, Mike, that go ahead.
overriding
Yeah, go ahead, you.
an underlying thing, and that is, as a technical person, taking responsibility for communicating, not just being technically correct, but communicating it to your audience.
Yeah, yeah, that sounds good. Well,
Well,
Phil,
one thing, yeah, I had an epiphany many, many years ago. Probably along the same lines that you had, Mike, is that thinking back to college and high school, that the most effective teachers and professors I had were ones that taught in an entertaining way. And that was the key to it, regardless of whether you're teaching an engineering subject, you're teaching a foreign language, whatever it is, that the entertainment was, getting in there. I'm not saying, go up there and juggle stuff, but you know exactly what I mean. And Mike, I got to tell you, I'd say you embraced that very thoroughly. I had the opportunity, I think about 4 or 5 years ago, to actually see you in action. I've known you for what, 20, 25 years, but we were both at the Long Island chapter, the SMTA, and we're both giving seminars. And I gave a seminar. There was somebody in between us. I'm going to hang around. I want to hear Mike talks. Man, you had everybody on the edge of your seat, entertaining. Everything from the guitar riff at the end to the some of your muscle cars, but you integrated it. There was nothing superficial about it. Everything just came together, and it was definitely, you're one of my favorite lecturers, Mike, because again, but you get it.
well, thanks. We are all three of us are members of the Mutual Admiration Society. So
yes,
right back
absolutely.
at
Yeah.
you, fellas. Right back at you.
Yeah.
You guys make me feel safe doing what I do. So
Mutual. It's mutual, Mike.
yeah.
Thanks.
It's
Yes,
like I'm
very
not
much.
giving up because Phil and Jim are still doing it. So I'm not going to be the only one carrying that torch. Well, fellas, thank you very much.
Thank you, Mike.
for giving up
Thank you
this
so
time.
much, Mike. It's been a pleasure.
Jim, you are now safe to go back to the beach, where I think you were having a much greater time. Yes. And yeah, hang 10, all that. Yeah, hang loose. All that. And Phil, enjoy. Is it Colombia that you're
Colombia,
in?
yeah.
And enjoy.
I'm down here for the coffee. Mind you,
Yes,
not the other
exactly.
stuff. Coffee. Yeah.
Yes.
Yeah.
Juan Valdez, right? Wasn't he
yeah,
the guy?
yeah.
Wasn't he the guy who personally
Yep.
curated the
For
coffee?
a friend of mine. Yeah, exactly. Yeah.
Remember the commercials of him standing next to his burro, with
No.
sacks of coffee beans in
That's right.
the satchels there?
I'm
Hand
living in
picked.
that dream.
Every bean picked.
Every bean, that's
Yeah,
right.
that's right.
Every
Yeah.
bean personally. Yeah.
Yeah.
All
Can't do
right,
better than
fellas.
that.
Well, keep up the good work. Something tells me you're not going to run out of work anytime soon. So I think you have the ultimate job security. And I'll just keep talking about what you guys do. So thanks again. For my audience who would like to get in touch with ITM Consulting, if you look at the show notes, if you're watching this on YouTube, look down where it says see more, and there'll be information on how to get a hold of these fine fellas through ITM Consulting. And if you're listening to this on your favorite podcast app, look at the show notes on your favorite podcast app, and that information will be there as well. Phil and Jim, thank you so much, my friend and my friends, and I appreciate you spending time with me and my audience, and I look forward to seeing you probably at SMT in October in Rosemont, Illinois. And
there we go.
I'm teaching a course. Are you guys teaching courses there?
Yes.
Yeah, we are.
All right.
Yep.
Well, I'll slip in on yours. You slip in on mine. If as long as
There
we're
you
not
go.
competing with each other, that would be terrible.
Never
Well,
know.
hopefully
We
we're
are
not
each
across
other
the-
very well, Mike.
Yeah. Hopefully we're not on the same track, but that would be great.
Yeah.
All right, fellas.
Mike,
Safe-
thank you so much for the opportunity. We really
Thank
appreciate
you,
it.
Mike. We really
fun.
appreciate you
It's fun.
inviting us.
You're two of my favorite guests that are on the show, and I'll look forward to the next time already. So take care, fellas. I'll talk again soon.
Great. Thank you, Mike.
Bye.
And everybody else, keep having fun. Thank you.
And that's a wrap on another episode of Reliability Matters. Thanks for hanging out. Whether you listened on your favorite podcast app or watched on YouTube, I really appreciate you being here. If you haven't already, hit that subscribe button so you don't miss future episodes. On YouTube, give it a thumbs up and subscribe so you'll know when new episodes go live. New shows drop every second and fourth Tuesday of the month, so mark your calendar. A big thanks to PCB Chat from the Printed Circuit Engineering Association at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Got a question or an idea for a future episode? I'd love to hear from you. Just shoot me an email at mike@mikeconrad.com. Just remember that's Conrad with a K. Want to learn more about the podcast? Head over to reliabilitymatterspodcast.com. Thanks again for being here. Until next time, keep learning, keep doing it right, and hey, reliability really does matter. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.